which intermolecular force causes acetic acid to have a higher vapor pressure than propanoic acid. So here we can see that the vapor pressure of acetic acid is higher, whereas both acids have similar dipole moments. And given that the molar mass of propanoic acid is greater than that of acetic acid, then we can attribute the higher vapor pressure due to London dispersion forces. And for clarity, we can draw these molecules, so just following CH3, and the carbons are bonded to each other, and then we have oxygen with another oxygen bonded to a hydrogen. And for propanoic acid, again we draw the carbons bonded to each other, and then we have H3 around one carbon, and then H2 around another, and then we have two oxygens and a hydrogen. So here we can see both acids can form hydrogen bonds with their molecules, and the propanoic acid molecule is larger. So the London dispersion forces are going to make it more polarizable.